Today we're going to be looking at some exponent review, and this is going to help us with the test that's going to be happening sooner rather than later. So the first thing I want us to look at is to state whether the simplified form is going to end up being positive or negative. Okay, so in order for us to determine that, we really have to understand the rules of parentheses versus no parentheses. Okay, in part A, if I have -2 in parentheses raised to the power of 6, the fact that the negative is in the parentheses tells us that if I was to do my repeated multiplication, I'm going to be repeating it where my base, I'm sorry, my pen is not cooperating here, where my base is -2, and it's going to have to stay in the parentheses. So this is my base. My exponent is 6, so I would then technically, if I was to do the repeated multiplication, have it written out 6 times. So let's think about this. Since the negative is being repeated, a negative times a negative is going to be a positive. Here we have another negative times a negative, so that's going to be positive. We have a negative times a negative, that's going to be a positive. So technically then, now I'm just multiplying by a bunch of positive numbers, and anytime you multiply positive numbers by more positive numbers, your answer is going to be positive. But the whole point was that we had to know that we were dealing with a negative that was being repeated because it was inside the parentheses. So then if we look at part B, we've got negative and then in parentheses -2 to the power of 6. Well, notice that if I just look at this part, -2 in parentheses raised to the power of 6, we already know what the answer is from part A. This whole entire thing is going to end up being a positive number. But I still have this negative on the outside. So that means that it's really like -1 times and then whatever that positive number is. Well, the fact that I want to multiply a negative times a positive, well, a negative times a positive would mean that we would then have a negative answer. Okay, in part C, we've got negative and then 2 to the 6th power. Notice that this time there are no parentheses. So when you're thinking about your repeated multiplication, you have to think of it as -1 times, and then the base is 2, and so 2 is being repeated 6 times. Okay, so because there are no parentheses, the negative is not included in my repeated process. So technically, all of these numbers here are all positives. When I multiply positives, I'm going to get a positive. So now we're kind of back to like part B. I've got -1 times a positive number. So that means that we would then have a negative answer. All right, let's take a look at a couple more problems. We're going to simplify the exponents. We've got a squared, b to the power of 0, c to the -4th. The fact that we've got 3 different bases, we have a base of a base of b, a base of c, that tells us when the bases are different, I'm not going to be able to actually combine the exponents. So we're just going to have to take it piece by piece. A is being squared. Because that exponent is positive, there's nothing that I can do to that a squared term. The second term that I have is a base of b, but it's raised to the power of 0. Remember, anything to the power of 0 is going to turn into the number 1. And so technically, if this is a squared times 1, well, when you multiply by 1, you don't really have to then write the 1. You write whatever the number is that you're multiplying by. So that means that because it equals 1, I don't even have to write the letter b anymore. Then I've got c to the -4th power. So technically, now I have, a squared c to the -4th, because like I said, if b is to the first power, b was to the power of 0 and it equaled 1, we don't have to write the b, and you don't technically have to write the 1 because we are being multiplied by these other terms. But c is being raised to the -4th power. I can never have negative exponents. So because there were no fractions, I have to think of it as a fraction by putting it over 1. Only the negative exponent terms have to get moved. So because a has a positive exponent, that's going to stay put. But the c that has a negative exponent has to move down to the bottom, which then changes the exponent to a positive. Because the bases are different, I cannot combine them any further, so a squared over c to the fourth is my answer. Problem number 2. We've got 5 divided by x to the third in parentheses raised to the negative second power. So whenever I have parentheses, I do have to think about that first. So inside the parentheses, if there was something that we could simplify, we would want to. Well, we have a base of 5, and then we have a base of x. Because those bases are different, I'm not going to be able to combine them. But because in parentheses it's being raised to the negative second power, this is a power to a power. So we have to make sure that we know each of the exponents inside. 5 technically has an exponent. If I don't see an exponent, it really has an exponent of 1. X has an exponent, it's a 3. Because we have exponents inside the parenthesis and it's being raised to an exponent on the outside, that tells us that it is a power to a power. I essentially am going to be distributing or multiplying that exponent on the outside to the exponents on the inside. So that means that I keep the base of 5, and on the top, the exponents would be 1 times negative 2. On the bottom, I keep the base of x, and then the exponents are 3 and negative 2, and those are getting multiplied together. So I keep the base of 5. I can multiply 1 times negative 2 is negative 2. Keep the base of x, and I multiply 3 times negative 2 is negative 6. Now remember, I can never have negative exponents for my final answer. Looks like we have a negative exponent on the top, which means that that has to get moved down to the bottom. Looks like we have a negative exponent on the bottom, which means we have to move it up to the top. So that means that now we will have an x to the positive 6th on the top and a 5 to the positive 2nd on the bottom. And then the last thing is we can keep simplifying this because we have an exponent of 2 and the base is a number. Think of that repeated multiplication. 5 squared is really just 5 times 5. We can very easily multiply two numbers together. 5 times 5 is 25. So x to the 6th all over 25 is my simplified answer. Here's another problem. They want us to complete the equation. We have r to the negative 9th times r to some power, and that equals r to the 5th power. So remember, when I want to solve the equation, that's technically because I'm going to put an x in for that exponent that's missing, and I want to solve for that exponent. So we just have to think about what is the operation that's happening over here on the right-hand side, so then I know what to do with my exponents. Because I see the same base being multiplied together, okay, because r to the negative 9th is being multiplied by r to the power of x. When I have the same base, it's technically like I keep the base and I add the exponents. So it's really like negative 9 plus x. On the other side, it's still r to the 5th power. But because I have the same exact base on either side of the equation, I can essentially ignore those and I can just set the exponents equal to each other. So negative 9 plus x is going to equal 5. So to solve for x, I need to move the negative 9. The opposite of a negative is a positive. So I'm going to add 9 to the other side. And then that gives me x equals 5 plus 9 is going to give me 14. So it looks like 14 is that missing exponent. One more problem. It says, what is equivalent to x to the negative 9th power? We're going to use the multiplication property, power to a power property, and the division property to show this. Remember, we talked about what equivalent means in one of our warm-ups in the past. Equivalent means that it's going to equal. So that means that if I have 3 different properties that I want to focus on, we're going to come up with 3 different problems that when I simplify, they're going to turn into the answer of x to the negative 9th. So let's first look at the multiplication property. We actually just looked at this in the last problem. It's when you have the same exact base being multiplied together. That means that you are going to keep the base and you are going to add the exponents. So since that's the multiplication property, that means that if I want my answer to equal x to the negative ninth, I'm going to have an x times an x, and I just need to come up with two exponents that when I add them give me negative 9. So there are 100,000 different combinations here. Like you can make up pretty much anything that you want. So how about if I have negative 19 for one exponent? What do I have to add to negative 19 to make it turn into negative 9? Well, that would be positive 10. So this x to the negative 19th times x to the 10th is something that is equivalent to x to the negative 9th power. So that would be my answer. Okay, let's take a look at if I wanted to do a power to a power. Remember, a power to a power, well, we actually looked at that back in problem number 2. We have an exponent inside the parentheses, so like x to the power of m, and it was raised to another exponent on the outside, like n. Remember, that means I keep the base, and I am going to multiply the exponents together. So essentially, I want to keep the base of x and have two exponents that when I multiply them together, give me negative 9. So there are several different things here, but I would say like negative 3 times positive 3. So negative 3 times positive 3 is going to give me x to the negative 9th. So here is my answer that's equivalent to x to the negative 9th. Okay, last problem would be talking about the division property. Remember, the division property is when you have the same exact space being divided and you have your exponents here. You are going to keep the base and you subtract the top exponent minus the bottom exponent. Okay, so I want to do that and have it where the difference is going to give me negative 9. So if I have x on both the top and the bottom, I need to come up with numbers that when I subtract give me a negative. That means I'm going to have a smaller number on the top than I will on the bottom. So let's say we have a positive 9 on the top. I would have to subtract 18. Think about it. 9 minus 18 is going to give us negative 9. So since this ends up equaling x to the negative 9th power, this would be my equivalent expression.